Now let's move to the beta screen by clicking this link in the top menu. Every beta coefficient from the model is shown in this table. Recall for age, at least initially, that we had a beta for 15 to 20 year olds, 20 to 25 year olds, etc. We have the exposure or weighted number of records in that band, the estimated beta, the standard error of that beta estimate, the Z value is the beta divided by the standard error, and there's a tick or cross to show if that beta is statistically significant or not. This shows a tick if the Z value is greater than 1.96 or less than negative 1.96, so it's further than 1.96 away from zero, essentially. Or it shows a cross if the Z value is between 1.96 and negative 1.96, so it's close to zero. Now 1.96 is a magic number in statistics, as it represents the 95% cutoff for the coefficients being significant or not, if those betas follow a normal distribution, which we assume they do, but for the purpose of GLM modeling. Now, statistically significant with a tick means that the estimated beta value is significantly far enough away from zero that this beta value should be included in the model. A cross means that it isn't significant and should probably be excluded from the model. Now, it's important to keep in mind what these betas mean and what it means when we say it is or isn't statistically significantly different from zero. The base level in a categorical variable, such as the 40 to 45-year-old band, because this was the level with the highest exposure, won't have a beta, but the other levels will. This beta is a measure of how different that level is from the base level. For age, the base level was 40 to less than 45. Band 15 to 20 was significantly different from this base level, and so is band 20 to 25, but the bands 25 to 30, 30 to 35, and 35 to 40 are not significantly different from the base level. They have this cross. On the face of it, we could group these levels with this base level. However, we might actually want to group them with, say, the 20 to less than 25 group instead. Or maybe all ages 25 to 40 should be grouped together. Now, judgment and domain knowledge play an important role here. We will look shortly at other diagnostics to help with grouping suggestions. In fact, we said earlier that fitting a spline to age might be better rather than grouping. Now, in the case of garage type, the base level was garage. We grouped that with carport, and street or train station or dot effectively is significantly different from garage or carport. The beta for a continuous variable, labeled as a linear variable here, is the slope of the line. A beta close to zero, or that isn't significantly different from zero, is effectively a flat line, or at least let's say that it shouldn't be a flat line. If it's a flat line, or if we can't say that if the model can't say that it shouldn't be a flat line, then whenever an observation is at one end or the other of that line, will have no effect on the response. So if the model can't say that a beta shouldn't be a flat line, then we should remove it from the model. In this case, both of these are ticks, so the slope is far enough away from zero that we can say that it's not a flat line, and therefore they should remain in the model. Now, the most important thing to use this betas screen for is that a tick indicates that this beta should probably be kept in the model, while a cross indicates that it should be removed, or at least the variable should be modified in some way to make it significant. Once we've progressed through the modeling process, grouping levels, fitted splines, and so on, we should come back to this screen and confirm that any factors remaining in the model are in fact significant. Lastly, this intercept is the overall balancing item. It's not associated with any particular predictor. Don't worry if this intercept is significant or not.